April 28, 1986. Deep in the Soviet Union, the central nuclear reactor at Chernobyl explodes. Within days, a cloud of radioactive debris drifts over dozens of countries spread across the globe. Friday, March 24th, 1989. In Alaska's Prince William Sound, the Exxon Valdez ruptures its cargo tanks. Tons of crude oil spill into one of the most vulnerable ecosystems in North America. Overwhelmed by the disaster, millions of helpless creatures die. Although a massive cleanup is launched, it may be decades before the full impact is known. Every day, 100 square miles of rainforest go up in smoke. This year's slash and burn deforestation will pump more than 1 billion tons of carbon dioxide into the atmosphere. In Great Britain, in the summer of 1989, water supplies are seriously threatened. The fountain at Trafalgar Square is turned off. As the temperature soars, London sizzles during one of the most oppressive heat waves ever. 3 of the hottest years on record were in the decade of the 80s. Today, in California, Los Angeles struggles to breathe. As traffic inches along the freeway, the fumes of this highly mobile society are choking the city. Southern California was once touted for its climate, but for the people who live here, the dream of the good life is rapidly becoming a nightmare. These incidents may seem unrelated, yet they are part of a single crisis that threatens the health of planet Earth. Scientists are alarmed by evidence from around the world of a rapid increase in global temperature caused by the so-called greenhouse effect. Locked in ice is an unsettling glimpse of the future. Are we changing the climate faster than any time in Earth's history? Join us as we confront the growing crisis in the atmosphere.
Because there is always knowledge to be gained, new paths to explore, and mysteries to unlock, the infinite voyage is made possible by a grant from Digital Equipment Corporation.
High in the picturesque Swiss Alps, little has changed in 300 years. For the people who live here, life is much the same as it was for their fathers and their fathers before them. But in recent years, the inhabitants of this alpine village have begun to worry about their famous tourist attraction, the Grindelwald Glacier. the vast sheet of ice straddling the eastern slope of the Eiger is gradually disappearing. Inch by inch, the glacier is melting. Bern, the 800-year-old capital of Switzerland, is a city of medieval architecture, of literature and science. Hans Oeschger is no stranger to the mystery of the glaciers. 30 years ago, he began to wonder about the climate. Could the glaciers be melting because the Earth's temperature is rising? Could the climate be changing? Oeschger knew the answer lay hidden in the past. Here at the University of Bern, he and his colleagues pioneered the technique of retrieving fossil air from ancient ice. Today, he is one of the world's leading authorities on the greenhouse effect.
Rudi, ich bin jetzt da. Ist alles in Ordnung? Ich gehe ins Labor runter. Ist gut.
The laboratory contains some 2,000 ice cores from glaciers around the world. For Oeschger, coping in sub-zero temperatures is all in a day's work. Glaciers form when winter snow doesn't melt the following summer. With each successive snowfall, the old snow is compressed until it finally turns to ice. Trapped inside are bubbles of air, tiny moments of antiquity that preserve the atmosphere from long before the dawn of civilization. The oldest cores come from polar regions where snow has steadily accumulated since the ice ages. In 1971, an international team of scientists began drilling on the Greenland ice cap. It was a colossal feat of engineering, but the results were spectacular. By 1981, they had drilled to a depth of more than a mile. Eventually, the core would span some 12,000 years. Fragments of the core were carefully preserved and catalogued before they began the 5,000-mile journey to Bern. The cores date back to the end of the last ice age, when the Earth began to gradually warm. Oeschger's team wanted to find out if there had also been a change in the chemistry of the atmosphere. To do so, they will measure the amount of carbon dioxide and methane, gases that trap heat in the atmosphere. Before the cores can be analyzed, the ice is shaved to remove any contamination. To release the bubbles of fossil air, the core is then put into a vacuum chamber and crushed. Oeschger and his team have now analyzed thousands of samples, and the results are startling. Chemical analysis reveals the origin of the carbon dioxide to be man-made. Since mankind began burning fossil fuels to power the Industrial Revolution, Carbon dioxide has increased 25%. Methane has doubled. Climate records show an increase in global temperature over the past 200 years. From the analysis of ice cores, Oeschger found that the rise in greenhouse gases in the atmosphere corresponds dramatically to the rise in global temperature. For Oeschger, the implications are profound.
What the man is doing, actually changing the atmosphere, that is happening now, and that's something which will lead most probably to significant climatic changes in the next 100 years or so.
Ancient air, trapped in ice, has given us a sobering glimpse of the past. But what can it tell us about the future? At the National Center for Atmospheric Research in Boulder, Colorado, scientists are peering into the 21st century to see if the current increase in greenhouse gases could change the climate. Here, the complex interactions that occur in the atmosphere are reduced to mathematical equations. Because climate cannot be reproduced in a laboratory, a machine simulates nature. A powerful computer can calculate a year of weather in hours. The result? A dynamic, three-dimensional model of the Earth's climate. By manipulating the factors that influence climate, scientists have created a crystal ball to look into the next century. Climatologist Stephen Schneider has seen the future. He is concerned about the increase in carbon dioxide and how it could affect the weather.
All of us have had the experience of feeling warm and cold days. We know one day can be 10 or even 20 degrees different from the day before. Well, that weather change is very large. Against that background where we live locally and think from day to day, how can we fathom what a 3 degree Celsius or a 5 degree Fahrenheit change is for the globe and over many decades? Well, the computer can actually help us understand that. In the lower panel, we're looking at a sequence of weather for normal. That means today's climate. Red is warmer. In this case, it means weather that's 10 degrees Fahrenheit or 6 degrees Celsius warmer than average, and blue is colder by 10 Fahrenheit or 6 Celsius. The upper panel is for a world that in the computer has carbon dioxide doubled, and that world is something like about 5 degrees Celsius, 10 degrees Fahrenheit warmer. Well, let's take a look in motion what happens. Now notice that down below, roughly equal amounts of hot and cold days, whereas in the CO2 doubled world, there's still some cold snaps coming across, but that the likelihood or probability of having warm is greater. We're still going to get weather systems coming and going. We're still going to have cold days in the winter, but the probability of getting red is much higher than it is in the normal weather, and the probability of getting blue is lower. But still, people are going to feel weather systems come and go in the future as well as in the present. The difference is we're going to have more extreme heat waves, fewer extreme cold waves, more droughts, and this can be very significant for forests, other natural ecosystems, for water supplies, for agriculture, human health, and so forth.
For billions of years, the average temperature of Earth remained stable and life-supporting because of the natural greenhouse effect. The sun's energy comes to Earth as visible and ultraviolet light. Eventually, it is released back into the atmosphere as radiant heat. Gases such as carbon dioxide and methane trap the outgoing heat, keeping the planet warm. But as man-made greenhouse gases increase, the temperature goes up and the natural balance is threatened.
Very often people in the public are confused about the greenhouse effect or any other complicated issue. For example, in the newspaper or on the television, they hear one expert who says this is catastrophic and we have to reform our ways immediately. And then somebody else, usually from an affected industry, who says, but there's a lot of uncertainty and we shouldn't do anything. That's a kind of thing that leads to paralysis. After all, if the experts don't know, how can I know? Very often what's not reported is that there's a spectrum of opinion, and that the media have grabbed the edges. They've grabbed the extreme and the extreme. And what's missing is that there's a vast bulk of knowledgeable and responsible people who don't believe it's either totally catastrophic or to be ignored, but that it's a problem in the middle, say an even odds of substantial change. And if the public knew that, and they knew that that was what the majority of people think, and my belief is that is what the majority of knowledgeable scientists think about global warming, then they would be much more willing to take measured actions to slow it down and buy time so that we can adapt more easily and understand what we're doing. Quite simply, we're insulting the environment faster than we understand what we're doing, and under those circumstances, surprises, many of them nasty, are virtually guaranteed.
Some of the surprises could be devastating. Consider this. By the end of the next century, a gradually warming planet could lead to the slow but relentless melting of the polar ice caps. As water is released into the world's oceans, sea levels rise. Storms increase in intensity. Low-lying urban areas are swamped. The familiar map of the planet is dramatically redrawn as seas surge across the land, creating new geographic outlines. Many of the world's major capitals are inundated, disrupting the flow of government. Fertile, crop-producing regions are reduced to desert. Agricultural patterns shift. Food supplies are severely threatened. Grain reserves in the industrial world dry up. No longer able to export food to an already impoverished third world, famine increases on an epidemic scale. Millions die of starvation. In a world of rapidly changing climate, familiar habitats begin to disappear. Entire ecosystems collapse. Planet Earth would be a very different place.
Sometime between 15,000 and 5,000 years ago, the planet warmed up 5 Celsius, that's 9 Fahrenheit. Sea levels rose 300 feet. Forests moved. Literally, that change of 5 degrees revamped the ecological face of this planet. Species went extinct, others grew. It took nature about 10,000 years to do that. That's the natural rate of change, if you will, for large changes in the system. We're talking about 5 degrees change as sort of a mid-guess for the middle to the end of next century as a better than even bet from our climate models. But this time it's taking place in 1 century, not 10,000 years. So we're talking about change that could be as much as 100 times faster than nature. It's that rate of change that has me worried, and that I believe the models are credible in projecting, not the details, because when you change that fast, you're almost guaranteed to have surprises.
Raid's here! Raid! 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 Raid!
Yes, Raid. Raid contacts and kills all kinds of bugs indoors. Raid hunts them down like radar.
Aerosol spray cans first made their appearance in the 1950s because of a remarkable new chemical.
Kills them dead.
Called chlorofluorocarbons, or CFCs. They were chosen because they were thought to be harmless to the atmosphere. Originally developed as a coolant, CFCs were commonly known as Freon. Now everyone could own a refrigerator. Outrageous stunts introduced the latest models. But even greater claims were made for the substance that made it all possible. Considered safe, They were odorless, non-flammable, and non-toxic. CFCs were marketed aggressively and propelled everything from deodorants to insecticides to food additives. They were truly wonder chemicals. Still in use today, mainly as a solvent for cleaning electronic parts and a coolant for air conditioners, CFCs were just too good to be true. But were they as safe as their manufacturers claimed? In 1973, a chemist at the University of California in Irvine made some simple calculations. Because CFCs have a long lifespan, Sherry Rowland wondered where they were going. What were they doing to the atmosphere? Rowland knew CFCs were harmless in the lower atmosphere, but what if they drifted into the upper atmosphere? Every chemist knew the molecular structure of CFCs and how they reacted to ultraviolet radiation. Soon, he sensed that something was very wrong. Rowland and his associate, Mario Molina, calculated that CFCs would not be as harmless as thought. Chemically, they would be deadly to the Earth's ozone layer. In the upper atmosphere, a layer of natural ozone protects the Earth from the sun's ultraviolet radiation. As CFCs drift above the ozone layer, harsh ultraviolet radiation breaks the molecules apart, releasing chlorine. When chlorine comes in contact with ozone, it robs it of an oxygen atom, destroying the molecule and forming a new one, chlorine monoxide. Reacting to a stray oxygen atom, the molecule becomes unstable and breaks apart. The chlorine is released, beginning a chain reaction. A single chlorine atom can destroy up to 100,000 molecules of ozone. When the two scientists announced their findings, many stopped using aerosols, but industry largely ignored them.
In December of 1973, I came home one day and my wife asked me, "How is the work going?" And I said, "It's really going very well, but it looks like we may see the end of the world."
In 1978, 5 years after Rowland's prediction, NASA launched a Nimbus satellite to study the Earth's natural resources. It would also monitor the ozone layer. By the early 1980s, its instruments began to record abnormally low concentrations above the Antarctic. While the satellite continued to orbit the Earth, researchers at the British Antarctic base at Halley Bay were measuring ozone in the skies above the South Pole. They began to detect a drop in the readings. By 1985, Chief Researcher Joseph Farman decided to publish the findings. He was convinced that there was a hole in the ozone layer. Ironically, the readings from the satellite were so low, the information had been ignored. Farman's discovery would force NASA to reevaluate their data.
Any problems that sort of help me incorporate them into the...
Atmospheric chemist Robert Watson thought that there had been an error.
We thought that the data was in some way flawed, that it was basically wrong. So we rejected the notion that there really was a hole in the Antarctic ozone shield. After Joe Farman reported observing the ozone hole, the scientists at NASA Goddard went back to their satellite data and started to look at it with much more scrutiny.
Hi, Mark. What you got?
Oh, hi. This is really interesting here.
At the Goddard Space Flight Center in Maryland, scientists compared the early readings to the latest satellite data. The proof was there. A hole had been torn in the ozone layer. Seen here in black against an outline of Antarctica, the ozone hole is now larger than the continental United States. To find out what was causing the hole, NASA dispatches its converted U-2 spy plane to the upper atmosphere to bring back air samples. A DC-8 flying laboratory will explore the lower regions of the ozone layer. High above the frozen wastes of the Earth's most desolate continent, instruments pick up vast quantities of man-made CFCs and traces of chlorine monoxide, or CLO, which trigger ozone destruction. The smoking gun had been found. Sherry Rowland was right. Robert Watson.
We believe that the ozone hole over the South Pole is primarily caused by man-made chlorine. As we flew south from Chile into the Antarctic region, that exactly in the right space and time coordinates, as the ozone hole went down, the CLO shot up. So exactly where we found the ozone to be destroyed, we found the CLO to be high. In fact, what we found was over the 6-week period between the middle of August and the end of September, the amount of CLO went up in time and the amount of ozone went down. We're quite convinced that it's this relationship between the CLO, caused by man-made chlorine, and ozone that is the primary cause for the chemical loss of ozone.
The Antarctic, home to an extraordinary diversity of creatures. We have long known that increased ultraviolet radiation can cause human skin cancer. What would the loss of ozone do to this delicate ecosystem? At the base of the food chain are phytoplankton. Next is krill. Without them, the sea would be lifeless. From these tiny shrimp-like creatures to the great whales, all depend on phytoplankton. Because ozone is a shield against deadly ultraviolet radiation, scientists are concerned that an increase in radiation would destroy the phytoplankton. Then the food chain could collapse. Around the world, the ozone layer is slowly diminishing. Life everywhere may soon be as vulnerable as the creatures of the Antarctic. Today, at the University of California in Irvine, a new generation is exploring the chemistry of the atmosphere. After 16 years, Sherry Rowland was finally credited for his work. CFCs have disappeared from spray cans in the United States and are no longer used in household products, including the insecticide Raid. Although some nations have agreed to curb production by the year 2000, the damage is done. CFCs already in the atmosphere will continue to destroy ozone for the next 100 years. Earth's delicate veil has been torn. Visible proof humanity is tampering with the atmosphere. It has been said, by our deeds we are performing a great experiment. Not in the laboratory, but on our own planet. Now the stakes may be too high to wait for the outcome. One need only look to the skies to see the crisis in the atmosphere. Greenhouse gases continue to rise. Carbon dioxide, methane, nitrous oxide, and even CFCs. Unfortunately, we live in an energy-hungry world. The United States alone consumes more than all of Asia and Latin America combined. So long as we rely on coal, wood, and oil, the largest sources of carbon dioxide, scientists agree that global warming cannot be stopped. But we can slow it down. Arthur Rosenfeld believes a key solution is energy conservation. He thinks the average citizen will respond to the challenge.
I think Joe Doe in Indiana is, in fact, likely to become scared fairly soon. And what he's going to be looking for is some leadership. He's not going to be impressed with ads for power cars. He's going to want to live in a society which looks after his interests and provides incentives and, if necessary, standards so that cars become even more efficient, buildings become even more efficient, and basically that the profit motive in our society changes. We have to fix it so that our oil companies and our utilities and our motor car companies and everybody make their profits from selling energy services and not for selling energy. If we think that the answer is energy, we will overinvest in energy supply, in oil wells, in coal mines, in power plants. If we think that what we want is energy services, we will invest in efficient cars and efficient lighting and efficient buildings and efficient airplanes, and life will be a lot simpler.
More and more Americans depend on artificial light, heat, and air conditioning for their comfort. Buildings alone consume 3/4 of all the electricity produced in the United States. At the University of California in Berkeley, new technologies for conserving energy are being explored. Here, Arthur Rosenfeld and his team are developing new products for commercial buildings.
Windows are a huge part of our energy expense. Something like 1/4 of all the heat from our buildings leaks out through the windows. We calculated that the heat which leaks out of American windows every year was about equivalent to the total output of the Alaska pipeline for a whole year, and we decided we'd better do something about it.
Window expert Stephen Selkowitz.
Here's the glazing technology that helps buildings stay cool. This clear glazing here has the same impact on cooling as the darker glazing on the left, but it lets through much more light, and light in office buildings like this is important because lighting energy consumption is a major energy use factor. Here's a material that switches when I push the button, much like the liquid crystal watch display that you probably have. When I press the button here, the electricity turns this from translucent to clear. It cuts out about 1/2 of the solar heat gain and 1/2 of the cooling load. So the next generation involves a different type of coating, and there's a prototype here. When we activate this electrically, you see it darkens, but you can still see through it. So this could be controlled by the energy management system in a building and adjust the transparency of the window up or down to keep the cooling as low as possible, but let the light in. We want to let the light into office buildings because lighting is a major energy use in office buildings, and that's another area for great energy savings.
Lighting in the United States uses somewhere between 20 and 25% of all our electricity. Now, since the United States is powered by the equivalent of 500 giant, or let me call them standard power plants costing $2 or $3 billion each, then lighting represents a demand of something like 100 standard power plants. At Lawrence Berkeley Lab, we decided that the first thing to do was to improve the efficiency of the fluorescent lamps, which you're used to seeing above your kitchen or above your desk at the office. They used to be run by an old-fashioned power supply. We've replaced it with this, which is a solid-state high-frequency power supply, which is not only flicker-free, but saves 33% in efficiency. That means that what I have in my hand here replaces about 1/3 of the 50 power plants in the United States which run incandescent lighting. This device will save over its 10-year lifetime about $100 worth of electricity. This is a regular screw-in bulb, so it can go anywhere that you're used to having an incandescent, but it's 4 times more efficient. And this bulb is pretty remarkable. It burns the same length as 15 of these bulbs, and yet it costs less than 15 of these bulbs. In the Bay Bridge in San Francisco, there are actually 2,000 lamps like this, except they're in a clear shell. This represents a huge savings in power plants, a huge savings in CO2 into the atmosphere, and an even huger savings in dollars to the consumer.
Whether it's a light bulb, a window pane, or a change in traditional values, conservation is clearly where the solution begins. Energy saved now will buy time to develop alternative technologies for tomorrow. Switzerland is a small nation of 7 million, less than half the population of Los Angeles, California. Still, there's a growing public concern for conservation. Highly industrialized, with an ever-growing demand for energy, Switzerland is also concerned about the crisis in the atmosphere. To reduce their need for fossil fuels, the enterprising Swiss are looking for alternatives. Clean hydroelectric power and nuclear energy are already in use. Now they have embarked on a new concept with a unique twist. Individuals produce their own electricity and sell it back to the state. Called cogeneration, it's now in use at a condominium complex near Basel. A generator fueled by natural gas produces the electricity, while exhaust heat is captured and piped through the building for heating and hot water. To regulate consumption, each apartment controls its own thermostat. For the Rickenbacher family, cogeneration means more than cheaper electricity and plenty of hot water. For them, it is an investment in the future.
Noch ein Gesicht waschen und Ohren putzen. Hörst du dich? So, ganz gut und dann können wir dann rauskommen.
Despite an excellent public transportation system, electrically powered cars are growing in popularity. The Frides Agency was one of the pioneers. Imported from Italy, Denmark, and France, the cars are converted locally from internal combustion engines. Despite the high cost, up to $16,000 a car, business is booming. Daniela Schlettbein, a physician in Basel, is one of the first customers. This small three-wheel vehicle can travel up to 50 miles on a charge and reach speeds of 35 miles an hour. On the outskirts of Basel, an environmental group called the Agency for Decentralized Energy has taken the idea one step further. Electric car owners rent space at a park and ride during the day. They plug in their car and the battery is charged while they're at work. The train to Basel is just 5 minutes away.
This box here is the measuring equipment for all the parts.
A meter measures the amount of electricity consumed by each car. Photovoltaic cells produce all the power required. The whole system runs on sunlight.
Everybody can take the solar car or the electrical vehicle, come here.
Although she has a busy social and professional life, Daniela Schlettbein is also a member of Switzerland's growing environmental movement. She has found her new electric car to be the ideal method of getting around. Although she's had to make some minor adjustments to this novel method of transportation, she remains firm in her belief that personal sacrifice is a small price to pay for a cleaner, safer environment.
Well, I hope you like that little car. There's no emissions whatsoever. It's very little noise. Of course, there's not a great speed, but I don't think it's so bad if you take the speed a little bit down in the roads. And of course, you can't go on a long distance with this car. But actually, if you think it, most times you take a car inside town. You don't take it for a very long distance, at least here. And you could very well take a car like this.
In Switzerland, individuals are making a difference. But in other parts of the world, choices are sometimes more complex. Southern California, once a mecca for sun worshippers and a city of golden promise, Los Angeles is now struggling to breathe.
Coming through downtown Los Angeles and not being able to see the buildings through the haze and the smog is frightening.
It seems like more and more people are coming into Los Angeles and learning to adjust their lifestyle to what is here, to what Los Angeles is all about. It's traffic, it's crowd, it's noise, it's smog. That's Los Angeles.
To commute every day on the freeways is torture. I can remember when rush hour traffic was in the morning and in the evening, and now it's like all the time. Nobody can believe what it's like unless you lived here.
I would rather get away from the traffic than get away from the smog. The smog, although it's bad, it doesn't bother me as much as the traffic times and the traffic hang-ups. I wouldn't give up my car.
A typical day in Los Angeles, seen in time-lapse photography, is compressed into seconds. At dawn, as thousands of cars pour onto the freeways, nitrogen oxides and hydrocarbons begin to fill the air. By midday, the sun's radiation cooks the mixture, producing man-made ozone. Commonly known as smog, it blankets the city. By late afternoon, the skyline has disappeared into the haze. It wasn't always that way. Barely 4 decades ago, Los Angeles still looked like the city Hollywood portrays in the movies. You could see the sky, and it really was blue. Today, Los Angeles has the dirtiest air in the nation. Now, the most ambitious air quality plan ever conceived is about to be put into action. It calls for the adoption of 120 separate air pollution controls to be phased in over a period of 20 years. Far-reaching and controversial, its goal is to achieve an 80% reduction in all forms of emissions by the year 2007. Industries, from auto manufacturing to aerospace, that use solvent-based products like adhesives and paint will be required to switch to less toxic substances. Even the chemicals used in dry cleaning will be controlled. Owners will be required to convert to combination washer-dryers to reduce the fumes from moving clothes from one machine to another. No aspect of life will go untouched. Individual lifestyles may be the hardest hit. Eventually, gasoline-powered lawnmowers and barbecue lighter fluids will be banned. The backyard grill could be a thing of the past. Norton Younglove is chief spokesman for the controversial plan.
There are critics that suggest, drop the plan, it's going to be too serious an effect on our economy and things of that sort. And my answer to that has to be that the economic effects of doing nothing are much more serious than the costs of doing something. For example, a $600,000 study that we commissioned and recently was completed indicated that on just a few of the health effects that are measurable alone, there's a $9.2 billion a year cost of just leaving the air the way it is.
In Los Angeles, life revolves around the automobile, one for every 2 people. To encourage ride sharing, separate lanes have been allocated to cars with more than 1 occupant, and yet, on any morning, they are hardly being used.
We have to change that love affair with driving all alone in our automobile to ride sharing, to public transit, to improving our health by using bicycles, by walking further than we're accustomed to walking. All of those things that help reduce the amount of pollution from the individual's vehicle. Up to and including World War II, we had really a very fine public transit system. General Motors and Firestone and one of the oil companies decided that they could make a lot more money by putting buses on the road and therefore get rid of that excellent, mostly electric rail system, and so it was literally thrown away. The worst sin ever perpetrated on 12 million people.
The streetcars disappeared by the 1950s. Now a fleet of 2,000 buses will be converted to cleaner burning fuels. But it will take more than that if the plan is to succeed.
The key to the solution is the broad American public. We can require of industry and others what must be done, but we cannot require, we can only ask of the public, help us please, because in doing so, you're helping yourself.
If the public cooperates, in the next decade, 40% of the automobiles in Los Angeles will also run on alternative fuels. The cost will be high, the sacrifice is great, but it's all a matter of choice. The people of Los Angeles now face a decision we must all soon make. What quality of life do we want to have? What kind of air do we want to breathe? From space, the Earth appears pristine and untouched. But as night falls, the artificial lights of the industrial world glitter across the continents. Fires herald the end of the rainforest, where third world countries struggle to survive. Invisible are the political and economic barriers that separate nations. Perhaps the single greatest obstacle to solving the crisis in the atmosphere. In Washington, D.C., the search for solutions is now part of the political agenda. Here, the threat of global climate change must now transcend national interests. While the choices confronting the industrial nations are becoming clear, the developing world faces a different dilemma. How to meet human needs and nurture economic growth while preserving the environment. A clearinghouse of ideas and information is the World Resources Institute. Jessica Tuckman-Matthews, Vice President of the Institute, works with scientists and advisors from over 50 countries.
One could get used to 3-day weekends. Okay, see you. In the context
Together, they have identified the critical issues we must act on now. Totally ban ozone-depleting CFCs. Reduce the consumption of fossil fuels.
Colombian ambassador asked about
halt the destruction of rainforests which absorb carbon dioxide, and stem the growth of a burgeoning human population, we must find new strategies for sustaining growth without harming the atmosphere.
Okay, and what's the energy growth rate?
For Matthews, the responsibility belongs to all the nations of the world.
To date, most of the contribution to greenhouse warming has come from the developed countries. On the other hand, it is not a problem that the developed countries can go off and solve by themselves. There are some developing countries, India, for example, in particular, has had a tendency to say, well, this is your problem, you created it, you go off and solve it, and when you've gotten your energy use under control, you come back and talk to us. That doesn't work either, because if you look at the future, 95% of all the population growth on the planet will be in the developing countries, and the vast majority of the energy use in the future of the growth will be in the developing countries. So nobody comes to the table with clean hands. The past may have been largely ours, the future contributions are largely theirs. So it has to be a problem where or an answer where the developed countries take the initiative, but that all countries really hammer this agreement out together.
Now the stakes may be too high to wait for the outcome. At the University of California in Irvine, a unique department has been specially created to study the causes and impacts of a changing climate. Head of the new department is atmospheric chemist Ralph Cicerone.
When you look at the causes of this accelerated greenhouse effect, you have to see all the countries of the world, all the people of the world together, and where future growth is probably going to occur, and where it is that people are going to be using more energy and more chemicals than they are now. This implicates the whole world. There are tremendous coal reserves in China, which may or probably will be burnt. There are people in developing countries where the population is going up very fast that are just becoming electrified. Electrification is occurring now. So we have to try to take all of those things into account, where the carbon dioxide and methane and CFCs and their substitutes are coming from. It's a worldwide picture. We have to look at all of the sources of these greenhouse gases. And then, how will the changing climate affect all of those regions of the world?
And then the final, I think, element of a global bargain on greenhouse will be to control population growth. Because this is a very different problem if global population levels off at 8 billion or 10 billion than if it levels off at 14 billion in the middle of the next century. So I think, although very little attention has been given to that so far, that the developing countries will also have to begin to make a much more concerted effort to control fertility rates.
What kind of world do we want? That's an interesting question. If we had asked that question 15 or 20 years ago, it would have sounded like how many philosophers can sit on the head of a pin. It wouldn't have had any meaning to it. But now that we've known that we are controlling the world environment, I shouldn't say that. We're not controlling the world environment. We're changing it without being able to control it. And we don't know where it's headed, but we're changing it.
What we should be afraid of is inaction on our parts, a refusal to face what's happening, to believe our own studies, to look at these graphs and these trends and understand what it portends for the future, even though we've never seen anything like this in our past. That's the thing that scares me, and that ought to scare everybody, because we might ignore it. We might wait until it's too late, and then we would have a very inhospitable planet on which to live.
I think great benefit's going to accrue to those nations that take the lead. There's some high moral ground to be captured here. It's like a hill in military strategy. The countries that take the high moral ground and provide leadership on protecting and stabilizing the environment are going to have more friends and more influence worldwide than those that show that they don't care.
Earth, with its thin, delicate atmosphere, is mankind's only home. It is the one planet we know that can sustain life. In contrast, Venus, Earth's nearest neighbor, has an atmosphere composed almost entirely of carbon dioxide, creating a runaway greenhouse effect. Here, temperatures reach 900 degrees Fahrenheit, hot enough to melt lead. Clouds of poisonous gas and the searing heat make life impossible in this turbulent and hellish world. The opposite extreme is Mars. Millions of years ago, mysteriously, it lost most of its atmosphere. Silent and cold, temperatures here plunge to minus 300 degrees. Ozone is so low that ultraviolet radiation bombards the surface. If life once existed here, it would have long since disappeared. From two nearby worlds comes a cautionary tale. The crisis in the atmosphere may be mankind's greatest challenge. The question we must now ask for our children and for their children is, what kind of world do we want?
Because there is always knowledge to be gained, new paths to explore, and mysteries to unlock, the Infinite Voyage is made possible by a grant from Digital Equipment Corporation.
For a transcript of this program and other educational material, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio 44240. Please include program title.
This is PBS.